Well, in my view, utilities traditionally is operated at disconnected silos, and one of those disconnected silos, obviously, are traditional demand-side management programs and efforts, which includes renewables and basically DERs, and then the standard grid operations. And there is a disconnection between these two, as these two things typically in most utilities don't talk to each other. So understanding the effects of demand-side management and renewables and storage on your distribution grid, and understanding what your distribution grid needs to accommodate in order to use and better understand and better run these sorts of customer-related end uses, if you will, is something that's missing. What is the impact of renewables on your distribution grid? What is the impact of storage on your distribution grid? Where you should have more additional, more DERs, where you should avoid having DERs, where you should have more storage, where you should avoid more storage. The biggest challenge is understanding the effect, the impact of these mainly customer touching technologies and tying them back to core utility operations. What do they mean to the operations of distribution grid? And what do they also mean to your traditional resource planning? Can you count on these? And how does this actually affect your traditional resource planning? Well, Nexant, we have a couple of different platforms. We have a demand-side management platform, which provides the ability to end-to-end manage your entire demand-side management programs, including renewable programs. And we also have a grid analytics platform that allow you to manage your grid-side operations. And we basically are what we're doing is bringing these two platforms together, integrating them, so now you can overlay your demand-side management on top of your distribution grid. You can do impact analysis, and you can use that analysis to better target DR, or renewable programs on certain parts of your network, or you can avoid them on certain other parts of the network. You can also look at how intermittent renewable penetration can change the load shapes on your network, if you will, and how you can actually use demand response, or EE, to flatten that load curve to better have a more predictable distribution grid with the inclusion of the renewables. So the grid needs to become demand aware, and the demand needs to become grid aware. So basically, utilities need to understand the effects of demand-side management and how it overlays on top of their distribution grid, and operationalizing demand-side management. And what that means is understanding where to target the energy efficiency programs, where to target demand response programs, where to target or not to target renewable programs, where to have or not to have storage to better manage the grid. And we strongly believe that there's a convergence of demand-side management and grid management, traditional distribution grid management, to better handle a far more dynamic problem set today and tomorrow. It's going to be a much more of a dynamic environment. I think customers are going to be much more engaged in the process. I think customers will be part of the grid as an ecosystem and not necessarily an endpoint. You're going to have, the consumers are now prosumers, and you have generation on the distribution grid. And I think the home will become what we call a subatomic grid, and I think a series of a number of those subatomic grids become nanogrids, and a number of the nanogrids become microgrids. So it's going to be a far more dynamic distribution network, and Nexant is going to be a major player in our view in that model, as we can help solve that problem with analytics and with predictive analytics to better solve a much more of a dynamic and a distributed problem.